Hello. In chapter 7, we cover the Black-Scholes formula. So in this video, you will see how to identify the inputs for the formula and then how to construct an Excel spreadsheet. And finally, how to program a simple VBA code for a function, for a specific function to use quickly Black-Scholes. So first, which are the inputs for the formula? We need to identify 5 variables. There are 2 prices. The first price is fixed. It's written in the contract. It's usually called the strike price or exercise price. And the second price has volatility. It's a market price. For example, if you are trying to assess the value of a call option, that means that you will find 2 prices. The strike price will be written in the contract. It's a fixed price at which you will be able to buy the house in the future. For example, let's say $300,000. And the other price is the current price of the house today in the market. It could be lower, it could be higher. So one of them has volatility, it moves. And that is why the option makes sense. Otherwise, you don't want a right to buy something that will remain at the same price. For example, if the house today is cheap in the market and you have a right to buy it at a higher price, then you will expect the market price of the house to move and to go up. So you will have a right to buy cheaper. And then the third input is the volatility, which in Black-Scholes is measured as the standard deviation per year of that price. And then finally, time to expiry, which means the time you have to exercise the option. After that, the option just dies, it expires. It has no value at all. It's a paper, you can break it. It's just a piece of paper. And then finally, as there are 2 prices that are in different points in time, one now and one in the future, the exercise price or strike is actually a price that will be paid or received in the future, then you need to capitalize or discount cash flows to be able to compare those 2 prices today and in the future. For example, let's say you would like to assess a call option. Remember that Black-Scholes will only be good for European options. Those are the options that will be exercised only the last day, the expire date. So there are 2 parts in an option contract, the buyer and the writer of the option. In this case, the writer is the owner of the house. And he will be obligated, he's signing a contract, and he will be obligated to sell whenever the buyer of the contract decides. Or we may say if the option buyer decides at the expire. So there are 2 parts. In this case, the option buyer has the right to buy the house. Let's say the house in the market is $300,000 today, and in the contract, we have the right to buy it for $320,000. In other words, this option is currently out of the money. We wouldn't exercise this option today, but in 1 year, we expect, if we are the option buyer, we expect the price of the house to go up, and then maybe we can exercise the option. So the risk-free rate in the economy is 3% per year, and let's say the volatility of the price of the house in the market is 30% per year, the standard deviation. So we have the 5 elements. We can perfectly value the house. A question that you may ask is, why would the option writer just sign this contract and be obligated to sell the house that cheap? Let's say that in 1 year the house may maybe worth $1 million, and he will have to sell it by 320, the exercise price. If any price will be paid or received in the future, it will be the exercise price. So why would he do that? Well, for the option premium, he will collect a premium. And how much should that premium be? Well, that's exactly what Black-Scholes calculates. The option premium, how much the call is worth. So let's work in Excel. Here we have an Excel spreadsheet. Let's value this option, this contract. On the left, on column D, you'll find the 5 inputs. The underlying asset is the asset that lies below the contract, that is behind the contract. That's why the option is called a derivative, because its value comes from another asset, which is, in our example, was a house. But sometimes it's stock. So that is why our first input, instead of being named underlying asset, it's just stock. So here the underlying asset or stock will be $300,000. Then the strike, which is the fixed price in the contract, is $320. The risk-free rate 3% per year. That could be like a T-bill rate. Then sigma, which is the standard deviation of the market price of the house, is 30% per year. And then time to expiry, 1 year. Pay attention to the inputs. They are all expressed in years. If, for example, you have an option that will expire in, I don't know, 30 days, you need to divide that by 365 in order to express it as years. And so now the Black-Scholes formula has 3 equations. You can see them on the left. And we need to calculate 2 numbers, D1 and D2, and then we can use the formula. So here in column G, you can see that I calculated some intermediate steps, like small parts of that formula, small terms. That makes it easier, but feel free to do it as you like. The first, sigma, I'm using names for the 5 inputs. So if you go to the cell where each input is, and then you go up there on the left of the screen to the name box, you can name each variable. That is very convenient because then you can read the name in the formulas. So sigma squared, I'm using the circumflex. You can use the power function as well, divided by 2. Then sigma times the square root. This is an Excel function, square root of time. Again, expressed in years. Then the natural logarithm. In Excel, the function is ln. If you're using Spanish, then it's raíz. That's why I'm writing Spanish on the side. Okay, then the natural logarithm of the stock divided by the strike. And then the next input is the present value. That is a continuous form for capitalizing or discounting. It's an exponential. So if you see the minus sign, it means you are discounting, you're coming to present value. But if it's a plus sign, if it's positive, if the exponent is positive, then you are capitalizing. It's easy to see because the number will increase when you capitalize and it will decrease when you discount. It's very similar to discrete discounting, where the elements were like 1 divided by 1 plus the rate to the power of the time. So the elements are the rate and the time in capitalizing and discounting. Well, this is the same, but it's continuous. This is because Black-Scholes uses like a very big binomial tree. And what they do is they shorten the intervals. So the delta t will be close to 0, and they extend the number of the steps. So n will go towards infinite. So that is why they use the continuous discounting form. So D1 and D2, You can see there on the right, the Excel formulas. And now we're going to use a function, which is the normal standard distribution. Make sure the S is there. This is what we used to, a long time ago, we used to do with a table, remember? With a normal distribution table on paper. Okay, so Excel makes it easier. And we do this for D1 and D2. This is the probability of a random number to be less than D1 or D2. Okay, and then we can finally calculate the call value on column G. And notice that Black-Scholes they didn't think of a formula for the put option. You need to calculate the call option first, always a European option, and then there's a put call parity to find the value of a put with the same exercise price and time to expiry. So you always will start with the call value, and then you'll move to calculating the put option. Okay, so we have all the inputs in, let me delete this. We have all the inputs in the previous steps, and now the call value. I'm using the last formula that you can see in line 17, more or less. So is ND1 times the stock minus, okay, 2 strike, the present value of the strike. Okay. And now the put call parity will give you the value of a put with the same exercise price and time to expiry. So in this case, the owner of the house should collect about a $30,000 premium for signing this contract. If time goes by and the house remains at the current price, then he will collect the premium, but nothing will happen. The option will expire, and the buyer will lose such premium. Okay, so now we can move to the equations in case you want to take notes. Here they are, D1, D2, and the call value. And there's a differential down there that is very convenient for programming in VBA. Okay, then you can also program some formulas for some functions for the Greeks that you will find them also in the book. So I will start here on column F and G. As you can see on column F, I have all the values of the previous steps calculated with using Excel. But this is like a long process. You need to go through several steps in order to find the value, for example, for a put option. What we'll do now is we're going to program a small code so we can have a Black-Scholes function in Excel, and simply inserting the inputs, we can find the value for a call or a put. So let's start with this. The 5 elements, remember, they are always the same. This is very similar to binomial or risk-neutral valuation. The only difference, small difference, is the volatility, which here is expressed as a standard deviation instead of an upside and a downside movement. Okay, let's work with a different example for the code. And this is at the money option. As you can see, the strike price is $100. The underlying stock is also 100. Volatility 20%, standard deviation per year. And time to expiry is 25 days. So we need to express that as years. And finally, the risk-free rate of return, 3%. Okay, let's start with the Excel. And on the right, I have a Word file. Here I will quickly program for our function. So let's insert the inputs first for this second example. This option, the contract was signed on November 25th. And let's assume today is December 20. So if we divide by 365, the difference is 25 days divided by 365. Time in years will be 0.0685. Okay. I will name it time. Then you see the name box up there? Okay, I will write strike time, then stock for the underlying asset, sigma for the standard deviation, which is 20% in this example, and rate for the risk-free rate. So I have names, 5 names, which are the 5 variables. All right. Okay. Now, let's work the code. There are many ways to do this. We'll try to make it simple, probably very unsuccessfully, but stay with me. Okay. First, let's program as for D1 and D2. So I have the function already in Excel, in a cell. As you can see, I have the inputs, and I have the function for D1. So let's start defining, let's put a name for D1. So as you can see here in Word, I'm writing D1. You can choose any name you like. And it depends on the 5 variables. If you check the formula, you'll see that D1 depends on the 5 variables. So I'm going to tell Excel that, I'm going to tell VBA that D1 equals 2, and I'm going to copy the formula, which is already there, is what we did before. It's already there. As you can see, it depends on the 5 variables. I just copy paste the formula that I had on my Excel spreadsheet. But now to translate to VBA, logarithm, instead of being called ln, is log. And sometimes points need to be replaced by commas or the other way around. And square root, the function square root in Excel has a T in the end, but VBA does not understand that, so remove the T. In other words, I'm telling that I'm defining a function called D1, which depends on the 5 variables, and I'm translating log, and I'm translating the square root, which you need to remove the T in the end. So it's just copy and function. Copy and you will have a function for D1. One more thing, as you can see, I'm using a circumflex, which is that small triangle above to calculate power function. So I'm adding a small code to tell VBA that whenever it sees a circumflex, that's a power. It needs to calculate a power, and that's an exponent. So as you can see, I added below, above, I added a function called my power. You can simply copy paste this function or write it. And just to tell VBA that that circumflex means a power function, an exponent. Okay, ready? So that's the code for D1. Now I need to go to the developers tool in Excel and paste this code. Okay, let's go to Excel. You might not have the developers tab, just you need to install it in Excel options. If you do, you will see it right on the right of view. That is. So go to Visual Basic, and I'm going to paste this code in module 1. I'll delete whatever is there and just paste this code there. Okay, there's a mistake. As you can see, I made a mistake. It's in red, so I just need some space between the parentheses. Okay, I'm adding some space. All right, I think it's fine. And sometimes you'll need to replace commas with points or vice versa. All right. Okay, there, another space. If it turns red, it means you made a mistake, like I did. All right. I'm only adding some spaces between the variables. Okay, let's see if it works. Yes, it works. Okay, I'll save. And now we can try using this D1 function, simply equal D1. Now Excel has a function for it. And we insert the 5 variables, stock, strike, time, rate, sigma. And only with that, all the equations should lead to the same result we had on the column at the left. So it works. Okay. Now, let's do the same for D2. It's pretty much it for all the formulas. I will continue, but feel free to, to try it yourself. This is it. I will continue with D2 and then with the Scholes formula, but that's pretty much it. If you got it with D1, you will be able to do it with all the other variables. Okay, let's work with D2. A moment. Here, okay. Let's work with D2. I'm going to write the code on the right of this. These are the equations. If you download my Excel spreadsheet, which is with the book, you will find the equations there on the right, and you will find an Excel spreadsheet with the code, VBA code. So you can simply copy paste the code. Remember to save the Excel as macro enabled book, okay? So let's work with function D2. First, I'll define the function. I named it function D2, and it depends on the 5 variables. Why? Because D2 depends on D1, and D1 had all 5 variables. So D2 equals 2, I'm gonna copy whatever I had here on the cell for D2 on the Excel, right? So it equals F6 minus sigma square root of time. But VBA does not know what F6 means. So what do I have on F6 cell? Oh, I have D1, and there's a function for D1. So I'm gonna replace it. Instead of F6, I'm just gonna write D1 and the 5 variables. Right. Okay. And remember that square root needs to be translated. Remove the t from square root. VBA does not understand square root in the same way Excel does. Okay, and function. So now you can copy all the code and paste it there. You can copy and paste in module 1. If you do not have a module 1 there, and you're not familiar with VBA, what you can do is you can record a macro. Go to the developers tab and just simply press record as if you were working like in, I don't know, with a stereo in your car, and you press record, play. Okay, press there, then stop, and record whatever macro, like moving around, a small macro. And then it will create a module 1. Then you can delete whatever is there and copy into that module 1. Module 1 will appear if you record a small macro. It doesn't matter. You can delete you can delete anything that VBA writes there. Okay. Now there's a differential function and I called it NDIF1. Remember that I had the formula there in the previous slide. So that's very convenient as well. Okay, NDIF1, which depends on stock, strike, time, rate, sigma. And I'm gonna say NDIF1 equals 2, then I'll go to Excel, I'll copy the formula, which I have on the last cell of column F, as you can see, and just copy paste. And now let's translate a little bit. This is more tricky. F6, what is F6? F6 is D1, so replace that. Remember to have my power command up there. And then we replace F6. Here. F6 is D1. So we replace F6 and we simply write D1 and the 5 variables inside the parentheses. Okay, have it there. I will copy paste, right? Instead of F6. Then X, VBA understands. Square root needs to be translated. Remove the T. Let's add some space, just in case. I need some spaces. And then there's the pi number. Can you see it in the end of the code? Remove the T and then 2 times pi. Okay, VBA will not understand the pi command, but what you can do is, this is number. So you can do is go to Excel, write equal pi, and you'll get the number 3, 14, 15, 93, what? You can find the pi number pretty much everywhere on the web or in your books, you know, from high school. That could work too. So I will just replace that and write the pi number. And that's it, and function. So I have function for D1, another for D2, another for differential D1. You can write as many as you like, all the previous steps for Black-Scholes. And then remember to copy all the code and replace wherever you had here on the VBA tab in module 1. Simply replace everything. When it appears in red, it means you're making a mistake. Here, I introduced the equal sign twice, so I'll remove it. Let's see if it works. Save. And then NDIF1 should lead to the same result we had on the left, 0.3981. Okay, let's try it. We write NDIF1, our new function, and then the 5 variables, stock, strike, and it works. All right. Okay, finally, here you can see on the bottom right of the page, and D1, the equation. That's the equation I was using with the pi number. Now let's work with the last one with the call value, and let's program this in VBA. This is the last part. We can program one for the put, for the European put as well. For all the Greeks as well, you can find them in the book. You can find a code for all the Greek letters in the book. Okay, 219 was the call value according to our Excel spreadsheet. Remember, we were working with this example for an at the money option. So now we need to program for the last Black-Scholes formula. So let's name it. I call it BS call, Black-Scholes call. Name it as you like. And it will depend on the 5 variables. As you can see, the third formula depends on D1 and depends on D2, and they all have the 5 variables. So we define function VS call, stock, strike, time, rate, sigma. Keep the order. And equals to, and I will simply go to Excel, copy whatever I had on the cell, and back to programming. Oh, sorry. Okay. Now, VBA will not understand F8. What is that? Let's replace F8 for ND1. We had a function for that. So ND1, we had a function for that, which depends on the 5 variables. So we'll find the function up there, copy and paste. Simply the name, just the name, and the one and the 5 variables in a parenthesis, and that's it. I'm replacing F8, okay, add some spaces, and then F10, what is it? F10, ND2, and we have a function. So let's find ND2 there. And again, we replace. You can do this for any formula you like. You can simply copy and paste. You need to translate small parts, but no more than that. For this, it's very simple. Okay, I will delete F10 and instead write ND2 with the 5 variables. Strike, X, break, that's it, end function. I think this will work. Okay, now we have a function for the VS call. And then you can add the function for the VS put, or you can find it in our book. Just copy it. We have a section with all the codes. You just copy it and paste in your developers tab. All right, here. So I made a mistake writing twice the equal sign. So let's delete it, and now we can try to see whether it works or not. So now we have a VS call for function in Excel. Simply inserting VS call and all the 5 variables, we should come up with the number of 219, and we did actually. Okay, so that's the Black-Scholes function, and that's all, my friends, for now. You can find more videos and this code and this Excel spreadsheet with our book. So I see you soon. Thank you.